Hi, I'm Mr. Stewart from Warren Middle School. Today I want to take the opportunity to go over operations of fractions with you. But before we go over the operations of fractions, if you haven't already, I recommend you view my video of Mr. Stewart and improper fractions prior to watching this video. Okay? So let's get started. Let's start off with the operation of adding fractions. Let's take 4 7s plus 2 7. Now take a look at this. What do you notice is the same? Okay. The 4 and the 7, the 2 and the 7. Both problems, what they have in common is their denominators. Both have the denominator of 7. So here's the key thing when you add fractions. You must have a common denominator. So with the common denominator, do you think you're going to add them? No. Because the thing is, my goal is to get a common denominator. Because 7. And if I have 4 and 2, that makes 6. And here's where that comes from. Notice, if you were to think about this, a pizza has 7 slices, and let's say 4 are remaining. Another pizza has 7 slices and 2 are remaining. So let's do this. 1, 2, 4, 6, 7. Okay? There's 7 slices to my pizza. Now ignore it. I know it's not proportional, so excuse me. 1, 2, 3, 4, 5, 6, 7. Okay? So 4 slices of my pizza remain. That's 1, 2, 3, 4. My other slice, 7 slices to remain. 1, 2. So in essence, I could just take those 2 slices from that pizza tray, slide it onto the other pizza tray that has 4 slices, because it's 7 slices total. Well, since my pizza tray holds 7 slices, how many is on there? 1, 2, 3, 4, 5, 6. And there's one empty one. That's where this comes from. I have 7 slices, 6 remain. So when you're adding fractions with common denominators, when you add fractions, you need to make sure you have a common denominator. Let's try another example. Let's say we have 1/5 plus 2/5. Or better yet, let's change it up. Let's say we have 4/5. We're adding 1/5 plus 4/5. So remember, my denominator represents how many slices I can hold. Okay? That's my tray. Well, remember, key, how many slices it holds, and it's got to stay the same. So if I remove my slices, that tray can only hold the same amount. So it needs to hold 5. My common denominator, or my denominator has to be the same. I'm trying to find a common denominator, and we already got it. So now we're going to add our numerators. 1 plus 4 equals 5. Okay? So let's go again to the slides. 2, 4, 5. Okay? 1, 2, 3, 4, 5. So if I have 4 remaining, 1, 2, 3, 4, and I slide over another one so I can get this tray back, that's 1. Guess what? Doesn't that fill up my entire tray? So is that a whole tray? Yes, it is. So when I have the numerator and the denominator are the same, that makes it a whole number. So that means it would then be 1. Because in essence, what it's doing is saying 5 divided by 5 equals 1. Okay? Now, here's where it can get a little bit tricky. When we don't have a common denominator, so let's say 1/3 plus 2/5. I have 1/3 plus 2/5. Now notice, do both of my trays hold the same amount of slices? No, they don't. My one tray holds 3 slices, my other tray holds 5. So what I need to do is figure out a way for both my trays to hold the same amount. And how we do that is we find a common denominator. Key words, common denominator. My 3 and 5, there has to be some way for them to remain, or to get a proportional. Okay? So here's the key thing I tell my kids to understand. What are factors of 3 and 5? And if we get to some numbers that you can't easily find a factor, remember, I can always multiply my denominators together and it will work out. Okay? But I know 3 can go into 15 and 5 can go into 15. So if I work this out, I know my denominator needs to both be 15. Now, when I set out problems like this, I do this visually because I want my kids to see 5 times what equals 15. 3 times what equals 15? Well, 3 times 5 equals 15. So if my denominator is 5 over here, I have to multiply my numerator by the same thing. So 1 times 5 is 5. So 1/3 equals 5/15. 5 times what equals 15? 3. So now if my denominator is 3, my numerator has to be 3. So 2 times 3 equals 6. So now do we have a common denominator? Once we get a common denominator, we can then add. So how many slices does my tray need to hold now? 15. How many slices are going to be on the tray? 5 plus 6 equals 11. So my answer would be 11 over 15. Now at our school, what we tell our kids to do when they have mixed numbers, when they have 1 1/2 plus 2 1/3, you can still add these types of numbers, but what we tell our kids to do is to make them into an improper fraction. Okay? You can work them out and you can make these a whole number, add those, and find a common denominator of this. Okay? But we choose to stay mirror in all of our teaching. So we go ahead and tell all of our kids to do an improper fraction. So this one would be 3 over 2 plus 7 over 3. Now I can find a common denominator. What's a common denominator of 2 and 3? 6. 3 times 2 equals 6. Put a 2 also in my numerator because it has to be the same thing. 7 times 2 is 14. 2 times 3 equals 6. Put a 3 here also. 3 times 3 equals 9. So now add them up. My denominator stays the same. 9 plus 4 is 23. So I have 23 slices, but my tray only holds 6, so I need to get some additional trays. So with that in mind, we're going to take this improper fraction and make it into a mixed number. And when you do that, you're going to get 3 5/6. And you get that from dividing it. 23 is your dividend, it goes on the inside. 6 is your divisor, it goes on the outside. So you would get 3 5/6. Let's take the opportunity now to go over subtracting fractions. Subtracting fractions, you have 7/8 minus 2/8. Now, adding and subtracting fractions both follow the same rule. You must do so with a common denominator. Okay? The bottom number. Both of my bottom numbers are 8, my denominator. So can I subtract now? Yes, I can. 8, then take 7, take away 2, you get 5. So my answer therefore would be 5/8. What if we don't have a common denominator? 7/9 minus 2/3. Okay. Are my denominators the same? We have a 9 and a 3. No, they're not. So before we can subtract, we must have a common denominator. Now my recommendation, I always tell my kids, I like to see them mirror it like me and how I set up my problem. That way I can first see that they can understand it. And then if they can alter and critique it for them, I'm fine with that. Okay? So what's the common denominator between 9 and 3? Well, if you think about it, 27 would work, even 18 would work. But why make as much work? Think about it. 3 and 9. Can I multiply 3 times 3 and get 9? Yes, I can. So 9 is going to remain my denominator. So 9 times what equals 9? 9 times 1. So 7 times 1 would equal 7. 3 times 3 equals 9. So multiply my numerator by the same. 2 times 3 would make it 6. So now can I add these up? You betcha. 9, and then 7 plus 6 is 13. So now I would have to take my improper fraction, make it into a next number, divide it out. And you would divide it out and you would get 1 and 4 9s. Okay? Let's go now to multiplying fractions. Here's the deal. If you've added and subtracted fractions, you've already done multiplying fractions. Because here's how you do it. Look, how do we do this here? We found a common denominator, right? 3 times 3 equals 9. 2 times 3 equals 6. Well, look at this 2/3. What is that? A fraction. What's this? 3 over 3. Is that a fraction? Yes. What did we do here when we multiply? Did we cross multiply? No. We only cross multiply when we're comparing items or comparing fractions. When you multiply fractions, guess what? You do it the exact same way. Multiply straight across. Okay? We multiplied 7 9s times 1 over 1. How do we multiply? Straight across. We've already been multiplying fractions, so it shouldn't be a new concept. But let's try it again. 5 6 times 3 4. Now notice, I'm no longer writing my fraction on top of a fraction. I went ahead and put multiplying like this because I want my kids to understand how do you multiply fractions? Straight across. It's like you're finding a common denominator. So 5 times 3 is 15. 2 times 4 is 24. Okay. Could that be reduced? You betcha. It could be reduced by 3. 3 can go into 15 5 times. 3 can go into 24 8 times. Answer would be 5 8. Let's do one more example with multiplying fractions. Let's take 11 12 times 3 4. 11 times 3 is 33. 12 times 4 is 48. Can this be reduced? Yes, it can. They both are divisible by 3. 3 can go into 33 11 times. 3 can go into 18 16 times. And it should be 11 over 16. So multiplying is the easiest one. Now let's go to the one that sometimes tricks students up the most. It's dividing fractions. Well, here's what we tell our kids. You have 1/2 divided by 2/3. 1/2 divided by 2/3. Here's what you need to understand. Change division to multiplication. Second, flip the second fraction, the reciprocal. Opposite of 2/3 is 3 over 2. So I changed division to multiplication. I flipped the second fraction. So now guess what I'm doing? Multiplying fractions. How do you do it? Straight across. 1 times 3 is 3. 2 times 2 is 4. So 1/2 divided by 2/3 equals 3/4. Do one more example. You have 5/9 divided by 2/4. Or better yet, let's change it up. Let's say 2/5. 5/9 divided by 2/5. Ready? Write your first fraction. Second step would be to change division to multiplication. Finally, we flip the second fraction. So instead of 2/5, it's 5/2. Ready? How do you multiply fractions? Straight across. 5 times 5 is 25. 9 times 2 is 18. Oh no, improper fraction. Can we do it? Yep, sure can. How many times can 18 go into 25? Once. 18 stays the same. What's my new numerator? Well, 25 minus 18 would be 7. 1 and 7/8. This concludes the operations of fractions. Hopefully you found this successful. Thank you for your time.